Hey folks, another NixOS video here. Today I'm going to talk about ZFS backups, and in particular using Syncoid, which is a project by a guy named Jim Salter. And it has a very nice sort of wrapping in NixOS that you can use to, if you happen to have data on ZFS that you want to back up. It's kind of like rsync, that is slightly better. So my root and home file systems are on ZFS, and I split them out into separate data sets. Data set is effectively a file system, so we can take a look here. If I do df.df, is it df? Is that h? Yeah. So I have root file system and a home file system. And the only reason they're split out like that is because NixOS, I wouldn't have bothered to split them out, but I knew that NixOS gave me all the same features as taking, continual ZFS snapshots of my root directory. It manages all that stuff for me, and I can replay it at will. So there's no point in snapshotting root because I can just blow it away and recreate it, using my normal NixOS rebuild stuff. So I have, my home directory. There's exactly one user, like most people, in my home directory, which is Chris M. And I would like to back up everything that's in home to an external USB enclosure that has a couple 5 terabyte drives in it. Syncoid is ZFS specific, so it won't work if you're using ButterFS or X4 or whatever. It's not for that sort of thing. Jim gave a talk about it. By the way, the link to this script, the gray stuff on the left hand side, will be in the description, and you can click on it and just get to all these URLs. But Jim gave a talk about the Syncoid project a while back. It's from 2015. And you can go watch it there. Under the hood, Syncoid uses this feature ZFS called ZFS Send /receive, which copies sort of a block level utility that copies changes from one ZFS data set to another, and it can either work on the same machine or across the network or anything. It's really, really cool. I did a video on it some years back that's linked also in this description here. The reason I'm using Syncoid is because instead of just raw, ZFS send, the video is about sort of using raw ZFS send and receive to do backups, but Syncoid actually manages snapshots for you, so you don't have to clean up old snapshots and other stuff. We'll get into it. The first thing I want to do is I have 5 terabyte drives in a USB enclosure, and I would like to create a new pool. And I would like to use that pool as a target pool for backups of my home data set. So the first thing I want to do is just show you what I have for the pools here. There we go. Or for the drives, rather. I have 2 5 terabyte drives. One is dev SDA, and the other is dev STB, and they have just crap laying around them from before that I want to get rid of. So you can I'm going to use this program called SGDisk, and you can install it using in your system packages by using the NixOS name GPT FDisk, it's called. And super helpful because it sort of clears out all these weird GPT metadata that you might have on your drive, plus it deletes all the partitions, so it's useful. So I happen to know, don't copy what I'm doing without thinking about it here, because you could really screw yourself up. This thing has no checks on what it does. It'll blow away whatever you type in here. So I know for a fact here that my drives are SDA. We'll just check it one more time. SDA, yes. Blow SDA. Zap all. And we can see that it zapped everything on there. Here's B. Yeah. Blow everything on there. Got it. Okay. Wow, that scared me. I think popped up. Okay. So these are the devices that I would like to use to in a mirrored configuration to be the target for my backups. And the way I'm going to do that is I'm going to use I'm going to create a Z pool, which is a pool of disks that is considered to sort of be for the same purpose for ZFS. And I sort of copied a lot of the stuff from an existing configuration I had, this A shift and everything. This is all kind of optimized stuff, but one of the important bits about it is that I could have said here, well, I'm going to just paste this in, it won't execute, I hope, that I'm using. I could have said here, all these options are sort of related to ZFS itself. They're not, you can go look them up, but they're not all that important. But the name of the pool that I want to create is B, and I want to, initially in the pool, I want to have a mirror of 2 disks. And here I could have said mirror, and then the next line or the next thing in there could have been dev SDA, and then the next thing could have been dev SDB. But that causes problems when you restart the computer, because drives don't get initialized in the same order every time, so it just gets confused. So you can use Linux's dev disk by ID feature to sort of say, yes, it is really on this disk that has this ID, whatever the ID is. And the ID is in the firmware of the drive. So I'm going to do this. It might have already executed because I couldn't see it happening, but cool. Okay. So now I created a Z pool, and let's see, is it already, would it be there if I did this? Z pool list? It is, yeah. So now I can see that it's 4.5 terabytes. And the thing I'd first like to do after having created such a thing is I would like this Z pool to be automatically mounted, or imported rather. I shouldn't say mounted. Automatically imported by ZFS at boot time, which I can do. This is configuration that's specific to this computer. I have all my stuff checked into to Git, and it's like for multiple machines, but this is only for this particular machine. So for this particular machine, I would like to boot ZFS. I would like at boot time for ZFS to import the pool B. And so that'll do that. If you're doing this for yourself, it's probably a good idea to reboot to see if it worked. I happen to know it does work, so I'm not gonna try it again. I can just mount it by hand, but let's see. I guess it's actually imported. Let's see. Sudo Z pool import B. I think it's probably already imported. Yeah, it already got imported by virtue of me running this Z pool create command. But the next time I reboot it, if I had not put this in here, the ZFS extra pools thing, it wouldn't be imported. So you wouldn't be able to address it in the later commands here that we have. So as I said before, I have a home data set. The home data set is in a pool called Nixroot, which we'll take a look at. So ZFS list R Nixroot. And I have in here a home directory. That's where my home stuff is mounted. I have a root, and that is on, that's just everything that's not home. Oh, sorry, there it is. I have a root there, that one. And I also have another data set here, test, that we're going to use for purposes of this video, only because I know what I'm trying to do is actually get my home directory backed up, but my home directory is kind of big. So for purposes of video, it's just, more informative and takes less time to use this smaller data set here. Okay. And so I'm just going to go into the thing that's mounted under test here, and we can see that it has a copy of Nix packages in it, just as something to, copy. But it also has another temp directory in it that has a bunch of files in there that are, very small, but number them, just so we can see things getting copied over. So the next step to this is to enable this service called Syncoid that I talked about. That's Jim Salter's project. And this is a, sort of NixOS wrapping to that thing, which works really well. Service to Syncoid enable you true, plus all the arguments to it. Currently, I have the interval set up for every time it'll try to back up every minute. And the reason I'm doing that is because it's just, it's easy to demonstrate in the video. We can see it working. So this commands is the meat of the thing here. And for the data set Nixroot/test, I want to back it up to the pool B in another data set called ThinkNix 512 test. The reason that I'm changing the name of it in the target is because I have other systems that I'm going to eventually want to back up here. And if I just called it test, then, it wouldn't be clear which machine it came from, particularly when it actually is my home directory. I don't want it to just be called home. I want it to be called ThinkNix 512 home. So we have a number of other things in here, like these extra args and send options and local source. Well, I'll talk about those in a second. So the Nixroot pool, that the thing that actually contains my home directory, it has encryption enabled at the pool level, which means that any data set that I add to Nixroot, anything like if I run Nixroot, all of these data sets are encrypted. The home directory, the reserved, root, and test are all encrypted. And I didn't have to when I created the data set, if I did ZFS create, and then Nixroot test, something like that, I didn't have to specify any encryption parameters because they're inherited from the root. But the B pool that I just created does not have any encryption parameters on it, and if it had, I would have had to specify them inside of God, what the hell? I would have had to specify them inside of the zpool create thing, which I did not do. And so one of the invariants of how I want the backups to work is that I don't want to encrypt my main drive, and then when I back up, have it all sitting there unencrypted. That would be silly, right? So what do we do about that? Well, we can make sure that Syncoid will send over the encrypted bits rather than the decrypted bits by telling it to use something called Raw Send, ZFS Raw Send. So in here, we have send options equal W. That means please don't unbundle my encryption. Please don't decrypt stuff when you push it over the wire, to this other drive as you do that. And that will just retain whatever encryption settings that it had on the source. It'll retain them on the target. So we won't have to re-encrypt it on the target or something like that. It won't be a thing. So these other lines here, extra args equal debug. This is just to be able to see stuff in our journal control stuff. I'm going to do a demo later, and if I didn't have this in here, it's pretty quiet, so it doesn't show much. These two lines here, local source allow and local target allow. These are just workarounds for a bug that's in the NixOS packaging of Syncoid, or maybe even in Syncoid itself, that lets us that prevents snapshots from old snapshots that Syncoid creates from being deleted. If we don't do this, then we just have a bunch of snapshots laying around that we don't need. So Also, as I said, the interval is every, oops, I said it's every minute. Here it's 15 minutes, but in my actual configurator over here, it's 1 minute. I meant to say 15. I meant to say 1. And eventually I'll change that to daily, just the word daily in quotes, because that's how often I want to back up. But just for purposes of this video, I'm just going to leave it at a minute. So Syncoid is configured that way. Or sorry, yeah, Syncoid is configured that way. I'm actually going to get rid of this. This was just a test that I was doing before. Pay no attention to Sanoid. That we're not using that yet. And now that I've uncommented that, I think I can run NixOS rebuild switch, and it should start. So I have the pool mounted, right? And it doesn't matter that there's no data set by the name of ThinkNix 512-test on the target pool, the target B pool. It'll get created as a result of Syncoid running here. So I think I can just rebuild. What I should probably do is I should probably make a window that shows us the output of journal control as I do this. And I might have to speed portions of this up because it might take a bit for Syncoid to kick in within a minute, but nobody wants to sit around for 30 seconds waiting for it. Okay, so we can see that it created a bunch of services and stuff. And the way NixOS does it is just super cool, man. It's just super cool. Like, I don't have to think about anything. I just type those. It's so cool. I just typed this to cloud configuration. It did all that stuff for me. Like it makes sure that my B is imported at boot time, and so good, so good, love it. But it also sort of does a little bit of magic for us that it actually does the backup under a username called Syncoid, and it gives temporarily. Okay, so Syncoid just kicked off there, so we can see what it's doing. Let me go back up here. Hang on. Press enter a couple times so we don't get confused. Okay, so we say starting Syncoid synchronization. Yeah, and it. Yep. So from Nixroot test to BThinkNix 512, and ZFS service, creating sync snapshot. Target didn't exist, and it is using ZFS Send to create a new snapshot on the target. Sending oldest full snapshot does this. Right. Okay, and now I can see the drive lights going. It take a little bit here. Next package is not very small, so this part I'll probably speed up. So we transferred 4 gigabytes over, and now we can the B data set that I created happens to get mounted at /B. As you see, it's a little strange. We don't have anything in there. Well, that's because we haven't mounted the data set that's in there. And in the meantime, I am going to, I guess I'll just let it go. I can mount this data set over here, and we're backing up from my internal device on my laptop to an external USB device. But we don't see the file system. But the reason we don't see the file system is because we have to mount it. So here's the really cool thing about ZFS. ZFS encryption in particular. So I can say sudo ZFS mount, and that is the target data set that I want to do. And it copied it over with encryption enabled, I can't get to it. I could send it across the network to, you know, to JRandom user's machine, and they would not be able to get into it with the proper ZFS send target. So, but I can actually mount it if I supply it with a key. Okay, I just can't type. All right, there it is. So now I should be able to mount it. Now, if I OSB, it's there. So Nix 512 test. Oops. B. We can see that it has approximately the same contents as our original. Exactly the same contents. I won't belabor the point by doing some MD5 hash or something like that. I know it works. But if I go to the source of what I'm backing up is in /test here, we can see that ALR test. Temp. That's probably better. We can see that the last one is FFA. If I do the same thing for B/Nix 512 test temp. It is also FFA. The way the Syncoid works is it takes a snapshot on the source and it transfers the snapshot to the target. And we can see that in sort of action by using this command here. That's the snapshot it took on the source. And so we should have an equivalent one on the target. Yeah, so we do have an equivalent one. It's the exact same target name. And those two snapshots, every time Syncoid runs, right now it's running every minute, it will erase the old snapshot, create a new one on both the source and the target, just so it keeps track of itself. So we now have backups running. They're not particularly good backups. They're kind of shitty, actually. In a more conscientious setup, we would right now what happens is that every minute the data that's in the target backup set is replaced by the data that's in the source backup set. So that means that if I wanted to restore from a file more than a minute old, I wouldn't be able to do it. I'd have to take whatever was there. There is a way around this. We could use a tool like Syncoid, which is made by the same guy, Jim Salter, or there's another one called ZFS Auto Snapshot, to take a snapshot of the source, the ZFS snapshot of the source, my home directory, and take snapshots, once a year, every 6 months, or six times a year, and then 52 times a year, and once a day, etc. And configure Syncoid to not make its own snapshots. Well, maybe it might make its own snapshots, but to copy those snapshots that are on the source over to the target. I don't think I really have space in my Nixroot ZFS pool to keep around all those old snapshots. I might. It's possible. I might be overestimating the amount of space it would take to do that. But for the purposes of this video in particular, but also in reality, any backup is better than no backup, and I haven't quite figured out the best way to do that sort of grandfather, father, son backup stuff. So I'm going to leave it as it is now. Now you might imagine that if you're paying attention here, you might think to yourself, well, you don't have to have the snapshots on the source. You could take snapshots on the target. So you'd only have the snapshots on the target for, you could run every once in a while, take snapshots of the target. Well, unfortunately, no, we can't do that. ZFS snapshots are not like Git branches. They can't have sort of temporally divergent stuff in them. They have to be consistent over time. So what what Syncoid does, it passes a flag to ZFS Send that says, hey, if you have any, in particular, you can't snapshots that are newer than the last time Syncoid ran on the target have to be deleted in order for Syncoid to do its job. And that's not Syncoid's fault. That is just how ZFS works. These are not branches. They're just snapshots. They're snapshots in time. So Syncoid passes this flag to ZFS Send that says, hey, if there are any snapshots on the target, delete them before doing this sync, because he could have chosen to do it the other way, which is don't delete them, but then the backup wouldn't work. It would just fail. It just can't be done. I'm not going to bother doing this stuff. I was going to run a demo that wrote stuff in here that we can see that it backs up and stuff. But what's the point? I know it does. You know it does. It all works pretty well. There's no point in backing up without testing and restore. I'm not going to do that either, though, because I know, because these are just file systems, I know that the data in here is the data that's on the other side. I can mount it and look around in it, and the only test that was really necessary to do was make sure that it mounted, so I can look around in it. So I'm satisfied with this for the meantime. If you use ZFS, leave me a comment in here. Let me know if this is interesting to you, and I hope this helps me. Thanks.